Welcome to this video on computational chemistry. This video covers only some basic aspects in computational chemistry for undergraduate students. The topics covered are: what is computational chemistry? Why is it needed? What are the methods adopted? What information are obtained? And which are some softwares used? What is computational chemistry? Okay, here we come to the definition of computational chemistry. Computational chemistry is a branch of chemistry that uses computer simulation to assist in solving chemical problems. It uses methods of theoretical chemistry incorporated into efficient computer programs to calculate the structures and properties of molecules and solids. Why is computational chemistry needed? In science, there has been a close connection between theory and experiments. Here is a theoretician. He is involved in mostly paper and pencil work. He derives equations based on theoretical models and hypotheses are formulated. But his work can be accepted only if the results are proved correct by experimentation. If the results do not match, the theory or hypothesis is discarded. But in some cases, mathematical solutions become very difficult to solve by paper and pencil work, or proper conclusions cannot be drawn from some solutions. In this process, assistance is done by computer simulation. The equation for simulations are provided by theory, and simulations give solutions to the problem. In some cases, while doing experiment, the data obtained like of a spectrum become difficult to interpret. The data can be used for simulation, which can then provide the interpretation for the experiment. This branch of science is called computational chemistry, where computer simulations give models to represent the real system. It saves time for both a theoretical and experimental work. Smart boy. So, it is as simple as this. If you are asked to calculate 3 into 8, you will immediately say it is 24. But if you are asked to calculate 3087 into 1072, you will use a calculator if you want the answer fast. So when complicated mathematical calculations in chemistry become difficult, computers are used. This is computational chemistry, and there are several softwares available for this. The methods adopted for this are ab initio. In Latin, it means from scratch. It is a group of methods in which molecular structures can be calculated using nothing but the Schrödinger equation, the values of the fundamental constants, and the atomic numbers of the atoms present. This is a highly accurate method. Semi-empirical techniques. These use approximations from empirical, that is experimental data, to provide the input into the mathematical models. This is less accurate. And molecular mechanics, which uses classical physics and empirical or semi-empirical force fields to explain and interpret the behavior of atoms and molecules. This is an approximate method. What information is obtained from all these? Electronic structure determinations like dipole moment, polarizability, geometry optimizations, which gives the relative energies of various configurations and their stabilities, frequency calculations, which gives a spectroscopic data like infrared spectroscopy, IR spectroscopy, NMR spectroscopy, definitions of transition structures and reaction paths, which gives you the reaction mechanism, protein calculations, that is docking, which is a process used in pharmaceutical industry for drug discovery, calculations of potential energy surfaces, calculations of rate constants for chemical reactions, that is in reaction kinetics, thermodynamic calculations like heat of reaction, energy of activation, etc., and calculation of many other molecular and bulk physical properties and chemical properties. So what are its applications? Computational studies are used to find a starting point for a laboratory synthesis. That is, you can decide which is the starting material and which reaction pathway has to be followed. And it also assists in understanding experimental data such as the position and source of spectroscopic peaks. As I said earlier, it is used to interpret experimental data. Computational studies are used to predict the possibility of so far entirely unknown molecules or to explore reaction mechanisms not readily studied via experiments. So it also gives you a possibility to explore something that is not yet found. Thus, computational chemistry can assist the experimental chemist, or it can challenge the experimental chemist to find entirely new chemical objects. Here is a list of software used. Games for valence band calculations, MOPAC, AMPAC, Spartan for semi-empirical methods, molecular mechanics, quantum mechanics, QSAR, CHARM, Gaussian, and the softwares are selected depending upon what results are needed. Thank you.